Okay, hello everybody. Thanks for being here. My name is Antoni, and well, we will change for a very broad and inspirational talk to something very, very concrete. Okay, here the question is that, as maybe you already know, with Jordi and David, we created different solutions on zero-knowledge proof, like the ZK rollup of Polygon, the IDEN3 Foundation, and Privado, that is the tooling of the protocol of IDEN3 that is more used in identity and privacy. And today we will address this problem, and this is one analysis that Eugenio has performed about how we enable these standardized executions through modular accounts, something very, very specific and very concrete. And basically, as an introduction here, we have this trade-off between the complexity of the executions, that each time are bigger, are more complex, are more heavy, we can say, and at the same time, we need to be compliant to address all the problems that regulators are scrutinizing, how the regulators are scrutinizing us, how we ensure privacy in the transactions, and at the end, how we find a balance between these two forces that they are trying to move in an opposite way. No? Then, one way to do it is through this modular contract account, which by one side, they allow us scalability because they have this composability aspect, which allow us to perform super transactions, for example, in the same block, which is something very, very concrete. And at the same time, this is adding this complexity of this Lego, of this puzzle, how you are able to ensure that everything is performing in the right way. And basically, here is where zero knowledge can help a lot, because as maybe you already know, all the data can be stored off-chain. Only the hash that is somehow is ensuring that all the data is correct is what it's stored in the blockchain. And at the same time, this is giving us the trust that the execution has been done in a proper way. Okay, then with this introduction, I pass to Eugenio.
Thank you. So, welcome everyone. What is this ZK validation model for contract account? I try to summarize here some Ethereum reference standards under three main pillars, let's say. The first one are two main core reference standards for contract accounts. So the standard ERC 437, which of course perform bundles to the mempools, the entry point contract singleton, the verification loop, and the execution loop. And we combine this with the modular setup, which is a minimal modular setup. We know there are two different ways of doing modular contract accounts, ERC 7900 and ERC 7579. In this minimal setup, we try to reduce at the best the performance that we can achieve by aggregating the ZK proof, the signature to the ZK proof, and do the batching essentially. The second pillar is essentially needed to enable the two smart contracts, the contract entry point, which is a singleton contract, and the ZK validation model to talk to each other. And the third one is the magic source within the ZK validation model, which is ERC 1271, which allows essentially to have a standardized logic for verified ZK SIG. So from product perspective, what kind of value we bring to the table? I wanted to use this slide to show that this actually product solution is quite balanced between compliance, which is given from data perspective in terms of offering on-chain data minimization and offering a standardized way to verify SIG, and adoption and user experience by providing, of course, the batching capability through signature aggregation and providing also a way to validate with different authentication rules one set of execution. So why user may need this? Because we improve UX, we enable, let's say, more complex use case, we enable user to ask many things that needs to be done on-chain. We can support enterprise adoption because enterprise care about compliance because it's a risk for them. And general source of truth, data minimization, because for not only for compliance, but also for network efficiency is very, very important. This is a project started a few months ago with the support of many different communities: the Centralized Identity Foundation, Identity, Ethereum Enterprise Alliance, European Blockchain Association, and companies from the industries like Privado ID, Rhinestone, and others. I wanted to give you a general idea on how a user flow may look like. So everything starts from the user. The user creates a verifiable credential, which essentially attests the ownership of a specific data to a specific signature. And then it generates a user operation as a message that wants to be executed on-chain, and essentially generate a ZK proof associated to that. Then the user operations fall into the mempool that, through a bundler, calls rely on-chain the entry point contract. The entry point contract executes the verification loop, so generate unknowns and may make the gas fee estimation, and then call the ZK validation module to verify the ZK proof which are generated to the user operation. And upon the verification of this, execute all the user operations on chain. A potential use case that we are actually testing at the moment, because this project started as a research and then is slowly evolving as a testing and development and testing environment, is, let's say, belongs the DAO environment. Because we, by interviewing different DAOs, Safe, Aragon, we understood that there was an issue in terms of engagement within the DAO. And essentially, this led to the fact that proposals that were made public on the DAOs were either approved or were not rejected because of people fearing expressing poorly their vote on chain. Because there is anyway a degree of transparency between the public address and the voting power. So this is where ZK can come in and establishing the eligibility to have this voting power without revealing the public address. And of course, we can combine these because we use contract accounts with batching, and essentially, if the proposal meets the threshold and get passed, essentially use contract entry point to efficiently execute funding allocation or whatever is needed by what is described in the proposal that has been voted. So we think that here, for instance, we create two big core value impact for the community. Firstly, we increase the engagement on DAOs, on members on DAOs, and we reduce the risk that there is a vote manipulation because of extreme transparency. And so we believe that we can enhance a better trust governance on chain. So the real clear message that I want to share here is that, in my mind, ZKP and contract accounts have a natural fit together with this setup, where ZKP offer data minimization and compliance for a client-side perspective, and contract account make the magic aggregating signature and aggregating items that needs to be executed on chain. So with this, I think that I can close for a moment and ask for a question. Mm-hmm. Yes, yes. Well, generally our analysis so far is that the cost of this solution, it's still relevant in terms of use case which requires multiple layers of aggregation. But considering the evolution of the technology and the amount of effort that the industry is putting in decreasing the cost of verification, we think that in a reasonable time frame, this solution will be very much viable from a cost efficiency perspective.
And also there is this component of, okay, maybe for certain DAOs, it's almost subsidized or it's free. But let's say if you want to vote in a government, as we're speaking with different governments in the world, then maybe they are more eager to pay because they need more security. No? Then here you can create like a different cost layer, because also it's not the same if you vote for a DAO for meme coins, whatever, but if you vote for a country
Yes.
to choose a president. No? Then, according to that, we are thinking on a different price model or cost model.
In terms of testing, I can't really now give you an estimation in terms of cost concretely, but also have a strictly reliant implication of where you are doing the proving, layer 2, layer 3, or on a layer 1 native. So we are doing the development right now, and we are gathering actually those kind of metrics.
I like that.
So my question is, you showed the example with DAOs, but can it also be used for hooks in Uniswap, for example, to make permissioned pools or anything related to DeFi?
Yes. Actually, for like a question of time, I just disclosed one use case, but we are actually thinking on additional use case. One is the one that you have been thinking, essentially for trading perspective. You can have users interacting with different trading platform, and they are sort of creating their own portfolio environment and essentially aggregating different ZKP according to the trading strategies that they want to execute. And then let the contract entry point to do the magic. Or additionally, I can tell you we are working on something which is more enterprise-oriented. So for instance, we have a lot of use cases in the blockchain where you want to track and trace things, and then you want to sell these things and use blockchain for traceability, yes? So you can combine this use case and having different suppliers providing ZKP of their milestone on the supply chain, and then potentially use the contract entry point to mint an NFT at the moment of the sales, where the contract entry point is managed by the distributor, the buyer, and essentially mint the NFT to the user after the verification of the ZKPs. So yeah, this solution is quite flexible and can be adapted to many industries.
Brilliant, Maury.
Thanks for the presentation, but I'm still in doubt that which part of the context or information can be ZK protected in your module, and is the ZK circuit in your module customizable or customizable by the users? Because you know different users have different text or context to be protected. So maybe someone may want to protect their identity, or someone or some other one maybe their asset or balance, such as. So I wonder that how the ZK circuit. I mean, how does the ZK circuit formed, and is that customizable or not?
Well,
Who are the ZK circuits?
I mean, the ZK circuit is customizable by users or not?
Yes, totally. I mean, we have created, for ZK circuits, you have all this program language that is named Circom, that was developed by Jordi and his team, and then, yes, it's totally modular, and you can create the conditions that you want. Then, yes, you can adapt it as you want. This is open source at the IDEN3 repositories. Then, yeah.
So you build a user interface based on Circum, based on Circum circuit, Circum language.
Yes.
Language.
Basically, Circum will be your base.
The idea here is really to create a standardized authorization framework to have the user operation executed upon the ZK verification. So what may happen is that the client, which is probably in the case of the DAO hosting the DAO environment with the modular smart contract, can have a specific custom ZK circuit built upon identified use cases that he wants to apply this product.
Oh, I got it. Yeah, now I know it's customizable. Great.
Do we have any other questions from the audience today? All right. Thank you so much for your presentation. We will begin our next presentation at 12:10. Thank you.